So without a doubt, the NanoVNA is one of the most versatile tools that a ham radio operator can have in their shack. And I'm going to show you today how to use this to be able to do simple measurements on your antennas. Now, my particular model is the SAA-2N. You can see that mine is 50 kilohertz to 3 gigahertz. It has two N connectors here on the top. Most of the NanoVNAs that you will see have SMA connectors. I purposely chose the N connectors one because I was using N connectors a lot in the stuff that I was using it for. But for all intents and purposes, they're mainly all the same, with some feature differences and also frequency coverage range. But just look up the features that they have. But this is the one that I've got. Now, the thing about this and what makes it really versatile is when you connect it to a PC using a piece of software called NanoVNA-App. And what we're going to do is we're going to have a look at sweeping a few antennas and see what results that we can get in a step-by-step walkthrough of how to do that. So the first thing that you're going to need is, you can see on the bottom, a USB micro. Now, I highly recommend that you get a decent cable, a decent USB cable. This is one that I've got here. So all we're going to do is just plug this into the NanoVNA. Now, as far as I am aware, I didn't have to install any drivers to make this happen, but I'll put a link in the description below to the NanoVNA app. So now that that's connected in, what we can do is go over to our COM ports. Now this has created a new COM port, which is COM port 8 here. And we can see that we've got a button here which says connected. It's automatically connected for us. And if we actually click continuous scan, all of a sudden we start to see some movement here in NanoVNA-App, and we can see that it's trying to scan through continuously over this frequency range. So at the moment we've got quite a wide frequency range. I don't need it this wide. So what we'll do is let's have a look at my 2-meter antenna. I've got a Diamond V2000 antenna outside. Actually, it's a tri-band antenna. So what we might do is we'll have a look and see what it looks like on the 6-meter band. We might start down at 45 megahertz and a stop frequency of 60 megahertz. So now that we're sitting there right in the middle at 52.5 in the FM portion of the band. Now with NanoVNA-App, you can select multiple points. They are multiple, think of it as multiple measurements along the axis of the frequency range so that we can get more accurate measurements. Because I'm on such a narrow frequency span here, which is 15 megahertz, I don't really need it. 1024, we might just stick with 201. Now, the next thing that we need to do is we need to make sure that this is calibrated. Go into the calibration tab here, which brings up a window, and this gives us the ability to be able to calibrate. Now, we'll just reset the SOLT, so short, open, load, through measurements. If I click short, it will give an error saying that your NanoVNA needs to be continuously scanning. So we'll go back up here to the menu and we can hit continuous scan. Just quickly, the play button here just does a single scan through. So if you want to just have a look at a single scan, you can. But for doing the calibration measurement, we actually have to go to continuous scan. Now, what we're going to do is get the calibration standards that we've got, and the NanoVNAs actually come with these. These are the N connect ones. They also come in the SMA ones as well. So on the top of the particular calibration standard, you can see that it's got short. So that's our short. We've got open. That's our open standard. And then we've also got our load standard as well. So the first one that we're going to put on is we're going to put on our short standard. Now, as I go through this calibration, it depends on how many points you've got will be how long it takes. It should give you a countdown here as it captures the short connection. Once we've done these calibrations, this is applicable to the frequency that we're actually scanning over. So I've just put on the open now, so we just hit open and we'll capture the open. So what I mean is that we're actually calibrating this for between our sweep here of 45 to 60 megahertz. If we change our sweep over quite a larger frequency range, then we're going to have to recalibrate again. So what we can do is once we've finished all of our sweeps, then what we can do is we can actually save this calibration. Now, one thing I didn't show, I'm actually plugging this in on the NanoVNA to the, I think this one's labeled port 0, which is the S11 port. So we've got the S11 port, which is the first port here, and then we've got a through S21 port. So because we're only measuring SWR, or we're only measuring the reflection coming back from the antenna, we only need one port. So we only need to do the calibration on this single port. And we can click Set Sweep. And we'll see now that our trace has now gone to 0 here at the top. Now, I did mention about the frequency ranges. So what we can do is we can go into here and click Save As. And this will bring up a window where we can now go and save our calibration file. So I'm just going to call this one 6 meters and hit Save File. So now what we've got is we've got a calibration of 6 meters, 45 megahertz to 60 megahertz, 201 points, and we're done. So now what happens is if I ever want to measure another 6 meter antenna, all I need to do is I don't need to go and recalibrate it all again. I can just load that calibration file. Now the other thing to note too is that I've calibrated it to the end of this port, if that makes sense. So that means that everything from here onwards is going to be measured. So from here to the antenna, which includes the coax as well. Now there's a little bit of a bonus hint here that what you could do is if you hook up your coax and you can actually access the other end of your coax, you can put your calibration standards at the other end of the cable, and then you can calibrate it, and then you can connect your antenna. And what that does is it will take out all of the losses and all of the potential issues that you might have in your coax cable to be able to measure the exact SWR and to measure the antenna at its truest, which is right at the feed point. I don't want to do that because I've got the coax and everything all as part of the system, so I want to see what it looks like here in the shack. Okay, so what I'm going to do is now I'm going to take my antenna and I'm going to plug it into that S11 port, and you can see there that we have a dip. So we've got a dip here. You can see if we look at the S11 live, and we've also got our statistics here on the other side, we can see that we have a dip right there. And if we have a look at the top right hand corner, you can see that the frequency there is 50.673 megahertz or so. We have a SWR of 1.20 or 1.208. And we also have a return loss of -20, or we have a return loss of 20 dB. So what we can also do is we can right click here on the graph and we can click Show Min Marker. So what that'll do is that will put a marker now right there where the minimum dip is. That is our best SWR, our best return loss. And again, that's at 50.7 megahertz. So if we've got multiple dips here, which we might be looking at a multi-band antenna. Now, if we go up to this button up here, you can see it's got New Graph. We can actually click on that, and this will show us a Smith chart of this particular antenna as well. If I make this a little bit bigger, we could see here that we've got at 50.7 megahertz sitting here on our Smith chart. But if we actually click on this little white text up here, we can also view all of these other parameters in this graph. So if we click on VSWR, there's our dip again. So this is now looking, we're looking at return loss, or our log mag in dB over here. This is now looking at our SWR curve. So this is probably going to be a little bit more familiar for beginners. We can also look at impedance. So we can see here that the impedance jumps up and down. So we're looking at the impedance of 50.7 megahertz, which is right there. We're sitting on that 40 ohms or so, or 42 ohms, I think it was. We can also look at now the complex impedance with the resistance and also the reactance as well. So at 50.7 megahertz, there it is. We've got our white line, which is our reactance, and our red line, which is our resistance. Now, if you want a NanoVNA cheat sheet, then I've developed one which is pretty basic, but it may help you to remember some of the more basic functions of being able to measure things. Have a look in the description below for that, as well as a link to this particular model of NanoVNA, the SAA2N, and where I got mine from. You can get these from Amazon and also from AliExpress. So now that I've measured my antenna here on 6 meters, let's now have a look and see what it looks like on 2 meters and 70 centimeters. So what we're going to do is stop that and change our start and stop frequencies. So what I want to do is I want to now sweep that entire range. So what I'm going to do is I'm going to start here at around about 130 megahertz. And I'm going to go up to 450 megahertz. Now, the reason why I want to do this is obviously I want to capture 2 meters and I also want to capture 70 centimeters, these two bands. You can see that they're highlighted in gray at the same time. But I've also been using this antenna recently for radio sons so that I can receive those. So I have no idea how well this antenna is actually matched on that frequency. And they're at about 400 megahertz. So I want to be able to sweep that as well. So we're going to stick with 201 points. Now that means that we're going to have to recalibrate again because we're moving away from our original calibration. So what we'll do is we'll go reset and we will go back into continuous scan and we will now click do the short, open and load calibrations. Now just quickly, I've got the red trace again here, which is the S11 trace. The S21 trace here, which is the through line one, we're not using and it's a little bit distracting and a bit annoying there at the bottom. You can get rid of that by right clicking here on the graph and going to graph type and change it to logmag S11 and that will get rid of it. Now the other thing too is that we've got a scale here going down to -100 all the way up to +10. We don't need that much of dynamic range, so what we're going to do is we're going to set the min scale here to about, let's go -50 and that's going to shift things out a little bit there. And then we'll go set max scale to 50. And then that means that our trace is now going to be in the middle of the screen. Okay, so what I can do is I can now plug in our antenna and we're going to see that some dips appear here. So there's our first dip that we've got here, which is at 140 megahertz. Now you could see, because we only have 201 points and we've got quite a wide frequency range, we've only really got one dip in there. We can't really see how accurate it is in that particular space. So what we need to do is we need to either reduce the amount of frequency that we've got, or we can also increase the amount of points that we've got. But for all intents and purposes, we can see that this antenna is resonant in the 2 meter band. And what we can do is we can drill down into that later on if we want. There's another dip here, which will be harmonic, I think, of 6 meters. So there's that dip there sitting at 194 megahertz. And what we might do is we might just go into the graph type here, and rather than showing our dips as return loss, let's just show it as VSWR, and that may make it a little bit easier. So now we've got a 1-to-1 SWR here in 2 meters. There's our second dip there. Now up at 400 megahertz, which is the radio son frequency, it is receive only, but there is an SWR there of 1.4. So it's not too bad. That's fully workable, especially for receive, because I'm not transmitting on that frequency. So the antenna's somewhat matched. I don't know exactly how well the radiation angle is, although it seems to receive the radio sons okay. And by the way, there's going to be a video coming up soon on radio sons and tracking those and what they're all about. So subscribe to my channel and keep an eye on that, because that is a very interesting thing that I've been doing recently. If we move a little bit further on, once we get into the 70 centimeter band, our SWR drops right down and we're below 1.2 to 1. And our lowest dip there, 435.6, which is very, very good, 1.028 SWR. Now, the last antenna to check is going to be my HRDX commander. So let's go and do that. So I've changed the frequency 5 to 30 megahertz. I've also increased the number of points up to 401. And what we'll do is we'll now stick it into continuous scan mode, and we can go to calibration and reset. Go and do our calibrations as normal. And because we're doing 401 points, you can see here that the calibration is a lot slower. And look at that, we've got quite a few dips going on here now. So my DX Commander I have pretty much on every HF band except for 80 meters. Here we've got a dip here in 40 meters, so that's saying 7 megahertz, 7.06. So we're sort of like a 2-to-1 SWR between 6.8 and 7.2. And again, we can drill down into this. There's another dip there around 10 megahertz where we're quite high at 4 to 1. The reason being is because my 80 meter element, the inverted L element, is down at the moment, and that heavily affects what happens on 10 megahertz. So that's the reason why. We've got another dip, which is a little bit low there in the 20 meter band, but it's not too bad. 2 to 1 or two SWRs, 14.375 megahertz. So we're covering, majority of the band there. I could probably shift that dip into the middle of the band at some point if I wanted to do some tuning. We've got 17 meters sitting in here as well with another dip. Here's another dip here at 15 meters. So we've got that one there. We've got one sitting here on 12 meters at 25 megahertz. And we've got another one sitting in here in the 10 meter band at the lower end of the 10 meter band. If we go up to the high end of the 10 meter band, then we're up above 2 to 1 there. But my tuner on my radio brings that in. Now, it's not just antennas that you can measure, but you can also measure coax as well. So in the next video, which is going to appear here on the screen, we're going to measure the loss of this coax. We're going to measure the distance and the length of this coax and some other parameters, all with the NanoVNA.